Okay, so our project is uncovering dementia signatures in EEGs with variational autoencoders by Ari and me and some biomarkers. So first, that's what we're gonna first look at biomarkers. Biomarkers are early changes in life that can showcase a change in biologically or physically. They're useful because they allow for early detection and they help track disease progression. Many neurodegenerative diseases begin years before symptoms, and biomarkers can detect these. The differential diagnosis is diseases like Alzheimer's and frontotemporal dementia often have overlapping systems, and biomarkers can help distinguish between them. With the use of VAEs, we can represent complex EEG data in a latent space to identify patterns and biomarkers between any different forms of dementia. On this chart, you can see that this is normal and this is abnormal. And here's an example of dementia. And as it goes up, it's showing how it's it's changing, it's mutating from a normal pattern to abnormal, as it shows here. So that's kind of what a biomarker is. So now we're going to talk about VAEs. VAEs are variational autoencoders, and they're a form of a generative deep learning model which forms compressed representations of data. Since it's a generative model, it can generate new images even though it might have not seen them before. It works by first compressing the original images into a simpler version called a latent space, and then it learns how to decode that hidden version back into something that resembles the original. It's kind of like it's compressing the data to create the same image, but in a much easier way to read. As you can see here, it has the same result, but it goes through this whole compression and it lets us read things much easier. Here's another example of how this works. These are the latent attributes that the most important features and attributes of what we put in the encoder is what comes out in the decoder in a much smaller compressed version.
All right, so what is Alzheimer's? Alzheimer's is like a disease that progresses over time and it worsens memory functions and dementia symptoms in the brain. Finding solutions about Alzheimer's is very important because this disease has very detrimental impacts on millions of families, both economically and socially. And so far, it's totaled to around $374 billion in healthcare. And about 7.2 million Americans 65 or older have Alzheimer's, which consists of 11% of that population, which kind of shows how it affects people who, like, affects mainly people who have aged. So now another type of dementia is frontotemporal dementia, and it's also a progressive degeneration of the brain, but mainly in the frontal and temporal lobes. Around 50,000 Americans suffer from this, which is around like 20% of the dementia cases. And it mainly affects people at around 45 to 64 years old, those who have also aged. And yeah, no, next slide. Now, the neuroscience behind these dementias. So, for Alzheimer's, abnormal protein deposits like amyloid plaques build up and they destroy like the neural communication in the brain. These changes for Alzheimer's mainly occur in the hippocampus, which can lead to like cognitive decline. And for frontotemporal dementia, the accumulation of these tau proteins in the neurons and the shrinking of the frontal temporal regions of the brain can lead to like impairments in behavior functions. And for this dementia, it occurs mainly in the frontal and temporal lobes. And as we can see on the image at the top, the left side is sort of like the normal, like control population. And on the right side, you can kind of see that's what happens to the brain in a frontal when someone has like the frontal temporal dementia. Like they they have like atrophy in certain regions, like especially in the frontal and temporal lobes, which means it's like shrunk in those regions.
So biomarkers of these dementias. So we talked about biomarkers, and now we want to figure out how to use them to detect these dementias early. So in EEG data, which is an electrical activity scan of your brain, biomarkers have shown potential for early early detection of Alzheimer's and frontotemporal dementia. One of the most seen early markers of Alzheimer's is an increase in theta power, which is the electrical activity. It's a measure of the electrical activity in certain regions of your brain, and it's usually in the temporal regions. But that's often accompanied by a decrease in alpha power, which is from 8 to 12 hertz, and it's a sign of cognitive decline, which is related to attention and memory. These changes can be linked to the accumulation of amyloid beta plaques, tau proteins, and gray matter atrophy in certain parts of the brain. Here is basically what we said. The theta power comparison, which is a biomarker of early detection, is the electrical activity. And the data set consists of 28 Alzheimer patients, 18 frontotemporal dementia patients, and 19 control patients. Over here in this chart that we've created, you can see the control patients and where their theta power is, the Alzheimer group, and the frontotemporal group. And here you can see there's increased activity in the Alzheimer's group, and the middle line here is the average of it. So the control is much lower, has much lower activity compared to Alzheimer's and frontotemporal dementia for theta power. And here's a topo map, which is basically an overhead view of your head. That's your nose is up here. So this can show where, what regions activity is happening the most in on the theta power scale.
So we also tried to find other connections, like between the control population and frontotemporal and Alzheimer patients, to try to find links between certain other data, certain wave powers that can like, help find differences between the two. So the first one was alpha power, which is a frequency of 8 to 13 hertz, and this is mainly associated with like alertness and memory and having a relaxed state while also being alert. And clearly from this graph, we can see that the control population has a much higher alpha power than Alzheimer's patients or frontotemporal, which could suggest that that certain wave power has like a certain has a certain part with symptoms of Alzheimer's. And with beta wave power, it's associated with active thinking and problem solving, and it has a frequency of 13 to 30 hertz. From this one, the median of the data powers were around the same for each of the three groups, so we can't really find a connection for that one. So for gamma waves, which are a frequency of 30 to 50 hertz, which is linked to like concentration, alertness, and creativity, there's also not much we can say because the median of each of the three are somewhat similar. But one thing that we can notice is the variability of the uh, frontotemporal table is much bigger than the other two. And lastly, for the last wave power we tested was the delta wave power, which is a frequency of 0.5 to 4 hertz. This is associated with like deep sleep and unconsciousness. And this one also, the median is similar. It's just like there's more variability in the frontotemporal patients.
So what our strategy is that we want to use the VAEs to compress the EEG data into a lower dimensional space that we can use to actually find out um, what patterns are going on in the data. So during training, the VAE forces the model to generalize across the subjects. It encodes the data as distributions, not fixed points, so it can help us signal patterns. And as a result, the features that differentiate the control group from the frontal temporal group and the Alzheimer group that can be shown in the latent space. So when we combine this with a dimensionality reduction tool like UMAP, these learned representations can be visualized to reveal any differentiable clusters for each group. And that can give us insight in how neurological disorders alter the brain activity in detectable ways. So we want to use this latent representation to find patterns and signatures of certain dementia disorders and to find solutions with that. This is our VAE model that we created, and this is the cluster you see. But looking at this cluster from our EEG data, oh, it was made from our EEG data, but they don't form separate clusters, all three of the groups. And that means that the EEG isn't providing a clear enough biomarker to help distinguish it. So the potential next steps that we have is we could specifically examine band specific features. So we just talked about the alpha, theta, beta, delta, and gamma waves, and we can see if any of those bands, specific bands, can produce separable clusters. And we can use that power to evaluate the topographic patterns, which is the overview of the head that I showed earlier. But yeah, according to this, the the EEGs don't give enough. They don't have enough biomarkers to distinguish the groups and separate the symptoms and overlapping symptoms.
So based on what we've found in total, we can maybe work on possible solutions in the future. So based on the data comparison graphs, the increase in data power in the Alzheimer's and frontotemporal patients can indicate disruptions in like the brainwave activity, which could be biomarkers for early like cognitive and memory decline. So like a possible thing that doctors could work on is being able to control like these electrical currents in the brain and help control the activity to slow down this cognitive decline. And then based on the four power waves we also tested, the main difference we found was in alpha power, and the decrease in the alpha power in the Alzheimer's and frontotemporal dementia patients indicate disruption like in the neural network in regions in the brain specifically like the thalamus and the cortex, which can stem from like impaired synaptic transmissions, which are basically like neurotransmissions. And maybe possible solutions to like to help with that is like with the use of non-invasive brain stimulation, we could like try to increase the alpha power in these dementia patients, which can help improve focus, memory, and the well-being of their brain. And this is the work side. Thank you.
That's it. Yeah.
Excellent, Aryan and Samir. Great presentation. You guys took 18 minutes. Need to present, okay. But overall, yeah, the content was great. A big difference from what I saw yesterday to today. So you guys have worked hard in the last 24 hours, I can tell that. Anyway, so let's see if you guys, if there are any questions. Okay, I see a couple of questions. So Geeta asks, at what age is it good to start testing for dementia? What are typical behavioral signs like simple memory loss versus something else more acute?
Um, so for that one, I don't think there's really like a specific age at which to start testing for dementia, but there's definitely like time where it should be more concerning. Like, well, first of all, symptoms could start as like early as your 30s, and then it worsens as you age. And some things to be concerned about is like if it's if it's like hereditary, like if your family members have had it, or like yeah, and some symptoms that you should look out for is like if a family member is struggling with like memory loss with like familiar events, or like disorientation in things that they're used to doing, and they're struggling in like normal tasks that they've done before, then these are all signs that you should sort of get it tested.
Yeah. And then to answer the other question, the challenges that we foresee in translating these EEG based findings, I think it's just the EEG data is very like complex and it's not really like easily readable. So to compress that and put it into a form that's like much easier to distinguish the symptoms, it's a challenge. So I think yeah, that's like a challenge for the future.
One other quick question. How large is a typical EEG data? And when you guys or when there is a plan to compress, is it lossless or is it lossy compression?
Oh, it's so let me double check the number, but what? So we had a 32,000 dimensional space, and using the VAE, we got it down to two dimensional.
Yeah, so but to complete the answer, the EEG data itself is like around that they used was around 10 minutes long, and uh, you asked is it lossy or lossless? It's actually a lossy compression. Okay, and what they did was they compressed the form a compressed representation, which was actually 32 dimensional. That was using the VAE, and then from 32 dimensions they went to 2 dimensions using another algorithm which is called UMAP. So yeah, so that's the complete answer. Yeah, but I just wanted to say something on what Geeta asked earlier. At what age is it good to start testing for dementia? Actually, there are not a lot of tests that exist. There are no blood tests that exist for detecting Alzheimer's disease, for example. Um, and people do PET scan, PET scan at fairly advanced age to see presence of amyloid plaques and neurofibrillary tangles. And there are some risk factors, though genetic risk factors that one could test for using things like 23andMe. So, for example, there's a gene called APO gene in which the allele epsilon 4. If you have that, then the chances of developing Alzheimer's is 4 times the average. Okay, so one could one could figure those things out. But suppose even if one does have epsilon 4, what are the lifestyle changes that one could take uh, to prevent Alzheimer's from happening? I don't think there is an answer to that right now. But we could say things like uh, keeping being fit reduces chance of developing neurodegenerative diseases. So if somebody is diabetic, for example, that really increases the chance of them developing Alzheimer's as they get older. In fact, Alzheimer's is nowadays called type 3 diabetes because of the close relationship between them. Anyway, um,
Thank you for that detail.
yeah, no problem. Yeah, also, just to answer Vishal's question, you asked a very good question. Is there EEG based, can this EEG based methods be used in clinical setting? As this project highlighted, it's figuring out the difference between the EEG signals in these three populations is very difficult. Even though they are using the most sophisticated machine learning algorithms that are there right now. Uh, so it would. So my guess is if something like this ends up panning out, it would involve some clever machine learning tools, which they are doing, and in addition to that, some statistics, some statistical analysis, and even then, we won't be able to say for 100% surety that this EEG is indicative of Alzheimer's. We could say it with some level of confidence, which is um, uh, uh, with some level of confidence, which it won't be close to 100%, but maybe something meaningful. Uh, yeah. So anyway, so the other question is, Aryan and Samir,
Yeah.
are there any side effects being tested?
Um, I don't think. Well, we haven't dived too deep into the testing part of it, but I don't think there would be too many side effects for it. It's like a normal screening, I think. Like I don't think it's. I
Okay.
don't think I'm not too sure about that, but I don't think so.
Oh, okay. So Vishal is saying there is a blood test for Alzheimer's, um, and yeah, it would be great if you could share
Yeah,
this.
hi Achint. This is Samek's mom. In Outlive by Dr. Peter Attia, he talks massively about the double gene, which is called ALOE, which you were mentioning earlier as well.
Yeah, good book.
This
Right,
this
yeah.
book this book is amazing, and it talks multiple times about that if early detected by the age group of 30 with certain exercises and keeping the cognitive behavior, it can really reverse the signs and symptoms of Alzheimer's disease. So you have the right book. It talks a whole chapter about the early detection of Alzheimer's disease by doing a blood test.
Did you say there is an actual blood test though? What's the name of it?
Yes, yes, it talks about it, and I'll be happy to share the chapter and the page number. You can look into Outlive.
Yeah, yeah.
Doing that proper test, which is not normally recommended into your normal panel test when we actually go for all the blood work. But if you ask for that test and if detected early early on around the age of 30. If you have double occurrence of that gene, it's guaranteed that you're going to have Alzheimer's disease. So by taking the right exercises and right diet and taking care of it, you can prevent the signs and symptoms of Alzheimer's disease.
Wait. I think you're talking about the Apo Epsilon 4 gene.
Yes,
Yeah.
absolutely.
So
Yes,
that increases the chances by 4 times. Yes. And if you have it from both the parents, then it
yes,
increases it to 12 times. Yeah,
right.
that is correct. But yes, suppose somebody has these genes, then the question is there any lifestyle changes that you could make which would,
Absolutely. Yeah.
yeah, which could with absolute certainty say that you won't develop Alzheimer's? And I'm saying I don't think we can say with absolute certainty.
Yeah, I think that there's research going on, and hopefully these people can take up on those research eventually.
Yeah. That would be great. Yeah, but the book that she's recommending, I also highly recommend it. Outlive by Peter Attia, and yeah, such a good book to think about how to age gracefully and how to um, reduce the sick span, the fraction of the lifespan that you are sick, to as little as possible. In fact, one of the sessions that we had during the boot camp was actually based on parts of this book. Um, it was on the aging session that we had was based off this book, and he talks about four main diseases. He calls it the horsemen of death: cardiovascular diseases, Alzheimer's or neurodegenerative diseases, heart diseases, cardiovascular health, and diabetes. And the biggest takeaway, especially for an Indian audience, is that cardiovascular diseases, it's something we think of as inevitable part of aging, and he he thinks that it's actually by with the right lifestyle you can really reduce the chances of uh, uh, developing it. So yeah, thanks for highlighting this book. I recommend it to everybody to read it. Okay,
Oh,
anyway, so let's see if there are any other questions.
yeah. There was one about if we still don't have a cure. There's no cure, but there are treatments. But the treatments, they just slow the decline, but they can only be used if you detect Alzheimer's early. So if you like start using the treatments once the decline is already like on the steep fall, then it won't really help. So,
Beyond genetics, are there external factors that can cause dementia, such as pain, medication, etc.? I think it's lifestyle. Having insulin resistance increases the chances of developing um, uh, uh, developing a dementia. So, so I know of that as a risk factor. But if you eat, if the lifestyle is good, you're exercising, you don't eat too much junk or sugary food, then uh, that reduces the chances of developing these diseases. Um, okay, so and it is still detection, and we still don't have a cure for Alzheimer's. Yeah, we don't have any cure for Alzheimer's. Um, there are so many drugs that have been proposed, and people have spent billions of dollars on it, and still it uh, like it sometimes it works on mice. So we have genetically modified mice which do develop Alzheimer's, and those drugs have cured Alzheimer's in those mice. But in humans, those tests have all failed so far. Um, but yeah, but a lot of progress is being done. Maybe in the next few years, we'll have something to detect it and maybe also help cure it. Okay, so let's see. Let's do the next session.